Now we're ready for the last page of our paper. So here we go. Okay, here we go. Here we go. What are you doing? All right, number 6. Now we need our note cards because these are the word problems. We're trying to figure out what formula we're going to be using. So here we go. Read question number 6 and tell me what formula we need.
Payoff.
So, of all the formulas on your sheet, which one are you using for problem number 6? PV. We're using PV because we are making payments to pay off a loan. That's when we use PV. So, our formula is this.
I can't help my bodily function. I was in the bathroom.
Too many details, sweetheart.
Well, I don't want you to like yell at me.
I'm not going to yell at you. You're going to bring me in a full-size non-generic box Kleenex. We need Kleenex, so it'll work out great. Okay. What is going where into the formula? What's PV? 9,200, right. What's R?
Nothing.
We don't know. Right? That's what we're figuring out. 1 minus 1 plus. Our interest rate is 0.0876. And are doing this how many years? 5 years?
12.
Monthly payments? 60 negative. That's a negative. That's a negative. Thank you. All right, so take a look at that, see if that's what you have on your paper. Ask questions if it's not. We good?
Yes.
Mamuna? If you're making weekly payments, you would use 52 for me. N is the number of payments or whatever savings things you're doing in a year. So monthly is 12. Okay? All right, well, let's type it in. Go ahead and type it in. Everybody knows how to do this. Let's start here, right? So I like to get that numerator taken care of. So you work on that.
Wait, Miss Moore, I have a question. When I like typing the numerator, wait a minute, never mind. I can put the -1 before it, right?
The minus is 1 minus that.
That's what I
Yes.
meant, yeah.
So yes, it's going to be 1 minus that. So there's the full answer up there. Let's see if we can all come up with that.
Bro, what? Explain. What was the reason?
Shock.
What? Who are you talking to? Not me.
I'm 17.
Think I can do another tuck?
All right, so our answer is you're going to have to make payments of $189.91. That's what you got. And we can't both be wrong, can we?
Of course.
No way. So, one more time. We don't have time in class to address your specific calculator issues. You know where to find me. Right after school, you can swing by today, and we can go over this. Or you could come in during flex, but not Tuesday because we don't have flex. We gotta get this straightened out. All right, here we go. Number 7. The increase in the length of a squash vine can be modeled by this equation. Is this squash vine growing longer?
Yes.
Yes. How do we know? That number in the parentheses is more than 1. Remember, that's how you tell if something is increasing or decreasing. All right, so here's my squash vine. X is in days, and Y is in centimeters. Okay? So Y is the length, X is the time. What is the initial length of the vine? How do we find the initial length of the vine? Well, you can actually look at your equation, because isn't this number the initial length? Or the initial value? But you can also, if it's the initial, that means X is 0. And what happens if you put a 0 there?
It's gonna be 1.
This is going to be 1
Right.
times 3.7 is 3.7, and that is centimeters. So the initial length of the vine is 3.7 centimeters. Okay? Now, how long is the vine after 9 days? So we're just going to go to our equation and plug in. No.
It's actually
Look
not,
at
is
the
it?
equation. Remember, if they give you the equation, you use it. And that says X. So I just put in X, which is 9. So 3.7 times 2.4 to the 9. I got 9774.69.
Centimeters.
A lot of centimeters. When will the plant be 50 centimeters long? When will the plant be 50 centimeters? What do we do? Plug in 50 for Y. So 50 equals 3.7 times 2.4 to the X. Everybody got that equation? Now we have to solve it, which means we're going to do what? We're going to, no, we do not log. What do we have to do before we log? You've got to divide by 3.7. So you have this decimal, which I'm going to go ahead and get on my calculator, but I'm not going to worry about it. It's 3.51 blah, 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 equals 2.4 to the X. You're going to see there's no need to write that whole number down. You can if you want. I don't want to confuse you. If you want to write it all down, write it all down. But you don't have to. You'll see why in a minute. What's the next step? I can't bring down the X until I take
out a
log. So I'm going to take the log of all this and the log of this. And that's going to bring the X out in front, right?
Right, yes.
And then I'm going to divide by the log of 2.4. So basically what you're telling me is I have to take the log of this big ugly number and divide it by the log of 2.4. Now that big ugly number is right on my calculator right now. So I'm going to do log answer, second answer, close the parentheses. Remember, you always have to close the parentheses, and then divide it by log 2.4. So your answer is 2.97 days. Yeah. Now, again, if you are not comfortable doing that, just write this number out. Write down all the decimal places and type it back in. There's no need to be panicking and confused. Second answer is supposed to make your life easier. And it does. But if it bothers you to use it, just type in the number again. All right. You deposit $300 in an account paying 2.4% interest, compounded monthly. Stop right there. Compounded monthly. You know what formula you're going to use in this problem. Compounded monthly means you're going to be using this one. You deposit $300. Where does the 300 go? P. That's what you're starting with. Your interest rate is 0.024.
Yes, sir.
Our compounded monthly. How much will you have when the baby turns 18?
That's really out of money.
12 times 18. And what is that?
216.
216?
Yeah.
So the question is, how much will you have when the baby turns 18? That's the formula we're going to use. Everybody okay with all those numbers? This is one that you can type in exactly like this if you want. Just make sure you're putting these parentheses here and you'll be all good. So, whoops, somehow I got something different. So 300 parentheses, 1 plus 0.024 divided by 12, close parentheses, raised to the 216. That's not as much as I thought. $461.90. Is that what you got?
Yeah.
When will your original investment be doubled? Now, kids, it's the same problem, so I'm using the same formula. But this time, I know A. What is my A? 600. Why does my A have to be 600? Because I'm doubling my original investment. Read the problem. $300 doubled, right? So 600 equals 300. 1 plus 0.024 divided by 12. Now, what's my exponent going to be?
Wait.
Mikey, 12t. Very good. The exponent is n times t. Do I know n? Yes. N is 12. We're compounding monthly. I don't know t. All right. I'm going to divide that 300. Want to go ahead and clean this up? 1 plus 0.024 divided by 12. So I got 1.002. Lauren?
For the first one, it's supposed to be at the edge, it's supposed to be -1.
What?
The thing is, at the equation, it's supposed to end it with -1. We're using a different equation.
Okay, I'm not making payments in this problem, Lauren. This is not, if we're on the right problem, I'm on number 8.
That's not wrong. I was saying for the first question, for question A.
Okay, what are you saying now?
She's saying using this SF.
This is the formula for question A. You only use FB when you are making payments. And in this case, we're walking down to the bank and we're giving them $300 $100 and walking away and not coming back for 18 years. That's different than if I say I'm going to save $10 every month for 18 years. That means I'm making $10 payments every month for 18 years. Okay, so you just got to read the problem. And the question that comes into your mind is, am I going in every month and giving them money? And in this problem, no, you're not. So you're not going to use that fee. You're going to use this compound interest formula. Okay? Another clue, Lauren, is the problem's going to say compounded something, compounded monthly, compounded daily. Okay? All right, so back to the action here. Let's gotta get this going here. What do we do? We're going to take the log of both sides. How do I know I need to do that? Because the variable is an exponent. What happens to that exponent? It goes in front. Very good. So now what are we going to do? We're going to take log 2, remembering to close our parentheses, divided by log 1.002. Now, what's on your calculator is 12t, right? So what do we have to do? Divide by 12. Just hit divided by 12. And how long is it going to take? 28.91 years. Come on, all right, let's get the Sean problem done. Sean was tardy once in the first week of school.
Good job.
He was tardy 3 times in the second week and 9 times in the third. So Sean's tardies look like this. If you pack up, I'm writing you a detention. We are not done.
At all.
Now, these are Sean's tardies.
Hold on now. I wouldn't even be tardy.
How many times will he be tardy in the 8th week? All right, what are we looking for? The 8th term. Very good. And the formula says that the 8th term is the first term times the ratio, which is 3 to the 7th power. So he will be tardy 2,187 times. Okay. By the 18th week, how many times will he have been tardy?
That's the sum.
That's going to be a sum. Does everybody understand that? That's going to be a sum. Right? And the sum of 18 terms is the first term minus the first term times the ratio to the 18th over 1 minus the ratio. Remember, when you do this problem, you want to simplify that denominator. So 1 minus 1 times 3 to the 18th divided by -2.
A lot of tardies.
A lot. So the answer is 1,937,10244. That is 193 million tardies for Sean. All right, and finally, problem 10. Let's get it set up, and then you can solve it on your own, and we'll check your answer next time. Your goal is to have $350,000 in the bank when the grammar's not very good there, in 22 years when you turn 40. So in 22 years, you want to have 350,000. How much would you need to deposit right now in order to reach your goal if the bank pays 3.6% interest compounded quarterly? I heard somebody say future value. No,
That's not.
I'm not making payments, right? I'm not making payments. I am going to use this formula.
I don't know who said that.
Now, no one's leaving until we get this set up. How do I know it's that formula? It says,
Compounded quarterly.
it says compounded quarterly. So, your goal is to have that much money. We want to know what this is. Interest rate is 0.036. Compounded quarterly. And we're going to leave it in there for 22 years. So my exponent's 88 because it's n times t. All right. Now, I want you to do that on your own. Get an answer, and we'll check it next time.
Unity, what?
Ashley, will you?
Somebody would say that. Like, that is obviously not.